Hey, Arturo, can you guys hear me? Yes. Okay, hi everybody. My name is Janet and we're about to start our intro to Python workshop. So we're having this workshop because one of our best professors, his name is Tony, he's going to be leading a machine learning and neural networks workshop. The first one is next week Tuesday at 5 or 4. Check your email. The one then the second one is the week after spring break. And we're doing these workshops because we want to see you guys be prepared for Rowdy Hacks in March 25th through 26th. So today we're not going to be using any heavy software. I assume that everybody has a Google account. So what we're actually, let me actually screen share. Hold on. So what we're actually going to do is we're going to go to this website called Google Colab. It's going to be the first link. Now, if you have Jupyter Notebook, I welcome you to use that. But either or works. So once you type in Google Colab, it's going to be the first link. This is the URL for it, collab.research.google.com. And when you're going to get to this page, and we're going to create a new notebook. And then you should see this screen. Give me 1 second. Okay. Is everybody here? Yes. Okay. So the first thing that I will always have you guys do is learn how to print hello world. I think it's the most essential thing you can ever do. So, type in the word print, and this is how you print things to your console. So you do print, parentheses, quotation marks, and then whatever you want to say. In this case, we're saying hello world. And then this button right here that's like next to the cell, that's how you run things in Google Colab. So you just click it, and then whenever it's done, it might be connecting and initializing in that corner, but you see it prints hello world. So that's how you do print statements in Python. It might be similar to like other languages as well, but that's the basics of it. If you guys are learning like Java or anything, you might notice that we don't use semicolons, which I think is a blessing, because I hate semicolons. So in Python, you don't need to add semicolons. So to add another cell, you're gonna click this button. Let me see the comment real quick. Okay. You're gonna click this button that says code right up here in like the second navigation bar. Is everyone there? Okay. The most important thing to learn is data types. Data types are very, very important because your computer, it likes to know if whatever you're typing is a string, which a string is just like it's just like characters. It could be a letter or any words and letters, words and symbols. It can be whatever you want. But what matters about a string is it has to be in quotation marks, right? So like let's just create, I'll just call it string 1, right? Is equal to quotation marks, and then we just type whatever. So this is a string. Hi. So I know it just came. Just go to Chrome and type in Google Colab. Go to the first link and then, yeah. Can you help him? Thank you. Okay, so this is a string. And right now it won't print anything, but a string is just a sequence of characters. It's the same in every single language. It's always going to be in quotation marks. That's how your computer knows that this is a string. The next thing is an int. So an int is just a number with no decimal, right? So if you notice, when I put in the word int, it's green, or it might be a different color for you. That's because in Python, there's reserved words. If it's reserved, it's going to have a special color to it. Like print is in yellow, and then int is in green because that's a reserved word in Python. So you can't use it just for anything. So I'll just add like 1. Int 1 is equal to, and then I'll put a number. Now, if it's a number that's like a value, you don't put it in quotation marks. So I'll just pick like 5. So it's just like in math, integers and decimals, but when you're coding, there's nothing called a decimal. It's actually just called a float. And once again, float is green because it's a reserved word. So I'll just add a 1 to it just to make it, not reserved. And then I can type in 4.5 or whatever. So the difference between an int and a string is the decimal. And then a string is just a sequence of characters. Next thing, sometimes when you're reading with data, sometimes you don't always know the data type. And the good thing is, he'll help you get set up. The good thing is you can actually just ask Python to tell you what data type something is, because it is important to know sometimes, especially once we get to machine learning. It's important to know your data types, right? So how you would do that is you would type, let's just say print, and then we're going to do type, and we're going to add parentheses again, and we're going to put like string 1. When you run that, it gives you this class string. So it tells you that this data type is string. Now, if we were to change this string 1 to one of our other variables, like let's say int 1, it would say it's an int. Your computer is smart, but you need to know how to use this type. It's going to be very important in machine learning. Next thing that's very important is in Python, there's something called lists, tuples, and dictionaries. When it comes to machine learning, we use a lot of lists just to store things. So a list is just something that stores multiple variables, right? So like, how we have this string right here, you can only add like one thing, right? And how you know it's only one object is because it's enclosed in only one pair of quotation marks. But you need to use a list so we can have multiple things. So I'm going to go to this line right here. I'll just call it my list. Sorry. My list is equal to, and when it comes to tuples, lists, and all of that, what makes them very different is they either use parentheses or brackets. So lists, they specifically use brackets. So you just do that. And let's just say in my list, I want to do fruit, right? So I'll do apple, comma, banana, comma, cherry. So do you see how it just has different strings enclosed into its brackets? That's what a list basically is. So if we were trying to do that here, it would give us a very big error. So, don't do that. Okay. So a big difference when it comes to lists and tuples is you can't change some of them, right? So if we were to make a tuple, once we make this, we wouldn't be able to add or delete anything from it. But in lists, we actually can, which is very essential. So when you start doing machine learning, you might be reading from data, right? But what happens if you have data that you don't want to use, or it's just messing up your results? You want to remove it, right? Which is why we use lists, because it actually lets us. But if we use a tuple, it would give you a very big error. It does not like changing things. Once you make your first your first tuple, it's final. You cannot change or delete anything. What you can do if you went into that is you can actually convert your tuple to a list, change the contents, then convert it back to a tuple. But that's very complicated for no reason, so we're not gonna do that. So we made our list, and the next thing we want to do is we want to learn how to access things, right? So imagine this list if it had like over 1,000 different things in there, right? What if I want to access only one singular thing? It could happen. So we're gonna type what is it? Sorry. Actually, let's do a print statement. So we want to print so we can actually see what it returns. So we're gonna do print, whatever you named your list, and then you do brackets, and then you're gonna do a -1. This -1, what it means is it's going to give you the last item. So if we were to print, it shows me cherry because that's the very last item in my array. So, and then if we were to change it to 1, it would give you banana. So you might be wondering, why is it not giving me apple? from 1 instead of banana. That's because in most code, you start counting from 0. So the first index, meaning the first place, is index 0. This is index 1, and that's index 2. So you guys remember how if we do -1, it gives you the last item. But you also access that one single item by just putting in 0, 1, or 2 if we want to only print cherry. So, yeah. Make sense? Questions? Are you good? Okay, sorry. Next thing is, what if we want to change items in the list? Sometimes when you're working with data, sometimes you might decide to change things after you already made your data. Instead of you having to go back to your Excel to just manually change the thing in your Excel, why not just do it from Python? Because it's so much easier. If you go back to Excel, you have to first change it, then save the file, then reload your code to actually refresh it to what you just changed it. So we can just do that directly from our Python code. So, actually, let's just back up. If you want to add comments, so you can like know what these things do, what you do is you do this and then just type it. So that's how you do comments. It might be useful, like if you're gonna go back and understand like what something actually does. You just, yeah. But okay, so let's change it. Let's do my list again, so your computer knows like what you're trying to change. So we do my list, brackets again, and then we're gonna do index 1, right? I want to change it to something else, so I'll just put black, and then let me just print it so you can see what it returns. Do you guys now see how, oh, that's kind of low, how initially in my list, index 1 was banana, and then I just changed it to black, right in this statement right here. And you can do that for other indexes as well. So if you're gonna change apple, you can do index 0. If you're gonna change cherry to something else, you can do either -1 or index 2. But sometimes, let's say we're working with data and we decide that, hey, honestly, I feel like I should just add more data because I just want more. The good thing about list is it lets you add things to it. So we can just do my list. So your computer knows what you're actually adding to, right? Dot, and then you type in append, parentheses, and then let's say I want to add orange, right? And to see if it actually worked, we can just print my list again. So now we've added orange to it. Append, in most languages, it just means add. Like you append something. So now we just added to our list. And also, one thing to keep in mind is this is one-dimensional. Like this is literally just one. If it was two-dimensional, it might be a little bit different to do these things, but right now just like focus on one-dimensional. So we were able to append to the end of the list. If we had like a list that was a lot bigger, that had like rows and columns, you'd have to specify what row and column you actually want to append to, because it likes to know exactly where you want to put something. Your computer hates guessing things. Your computer hates guessing games. It wants you to be straightforward and just get to the point. Everybody good? Am I going too fast? Okay. Okay. Sorry. Look away. Yeah. I see you looking. Okay. Next thing we want to do is, what if we want to remove something from your list? So it's the same thing. So we just do my list, and then we type in the word remove. And sometimes if you don't know like if the word exists, if it does, it's gonna pop up just right there. If it didn't exist, I'll just, nothing happens. So dot remove. And then your computer now wants to know what am I removing from your list. So now this time we're not using brackets, we're using parentheses. And let's say I want to remove the string. I'll remove orange. I don't want it there anymore. And then again, we print my list just so we can see its actual result. So now do you guys see how from this first list, we were able to append something to the end of it right here. And now we're also able to actually remove things from the list. I think we've had enough of lists. So let's say you are working with data. So we talked about data types, right? We have ints, floats, longs, characters, like there's a lot of data types. Sometimes you want to convert to different things, right? So what if I was doing math and I want only even numbers? I don't want decimals. And the user gave me a decimal number. I don't want that. We can do something called cast typing, right? So we can just make a variable called z, and then we can just do float, right? And then parentheses in quotation marks, put in a 3 or any number, right? And then let's print z and let's see what it returns. Do you see how 3 is currently a string because it's enclosed by 2 quotation marks? Yes. Does that make sense? Because we can go back to the top. So a string is a sequence of characters, and it's enclosed by quotation marks. An int is just an integer that has no decimal to it, so just 5. A float, it has like a floating point number, or it's just like a decimal. So a float would be 4.5, 4.3, 4 point whatever. So like if I was to ask you the difference between 4 and 4.0, the difference is 4 is an int because it has no decimal, and then float 4.0 is a float. So if we go back, sorry, if we look here again, this 3 is enclosed by quotation marks. This is a string. And by cast typing, I tell it, hey, can you convert this to a floating point number to have a decimal? Now, it won't convert it to 3.5 because what does that make sense? Instead, it makes it 3.0. So this is very, and you can do this for all data types. So if I wanted to convert this to an int, I just type in int and it would convert it. Now it's just 3. Carlos, are you good? What's I saw you want your computer. Double. Oh. Hey, get on one of the PCs. I'm talking to him, sorry. Hey, really? Isaac, are you guys good? All caught up? Yeah, just your like profile and then just add it. Okay, so are we good to move on? Do we need to slow down or anything? Good? Okay. The next thing that we're going to learn is conditional statements. Um, your computer likes to know how to react to different situations. So what if you give your computer a math problem and it's wrong? Or sometimes when you're writing code, you don't want to have to deal with things if it's not your expected output. So what we do is we have conditional statements. That just means, hey, if this condition is true, then do this. If it's not, then do this. And if it's just all wrong, then just throw me an error. So we're first going to focus on if statements. So how you do that, okay, so first we're going to define some variables. We want them to mean something, and they're going to be numbers, right? So let's just do A is equal to 33, and B is equal to any number that's like less than 33. So I'll just do 23. And if you guys know Java, the difference between what we're doing here and in Java is that in Java, it likes for you to tell it exactly your data type. So you might have to be like, int A is equal to 33. Python does not like that because Python's a very lazy, straightforward language. So it just knows. It's very smart. So like let's say we're doing some math operations and we want our computer to, like, if we ask the user to enter like, hey, can you give me two numbers? If you want to add them, subtract them, or compare which one's bigger, you need to, be able to deal with them, right? So how we start it is we just do if, right? Like let's say want to deal with like if B is greater than A, right? And when you're ending your first if, you need to put a colon at the end of it and then press space. Now, Python is very case sensitive. So do you see how it didn't just go like right here to be like aligned with the if and all of them? It's very case sensitive. When doing loops, Python likes indentations. It likes spacing. So if you're getting errors in your loops, it's probably because your indentations are probably wrong. So I'm going to do if, and let's say if this condition is true, meaning if 23 is greater than 33, we want it to print B is greater. Oh, crap. Sorry, guys. I'm not sure what happened. We're just doing conditional statements. So we had to define values for A and B. So my A is equal to 33 and B is equal to 23. Then we have our if statement and we're saying, hey, if B is greater than A, then do what's in this print statement. And when you're ending your if statement, you need to put a colon there, and it's very case sensitive. So if you notice when I click enter right here, it indents like by one space right here because in Python it does care about how you indent. So that's how you missed. But in this condition, we're saying, hey, if 23 is bigger than 33, then print B is greater than A, right? And then we want to do an else if because a different condition could be true. So we do EL, then if. Let's say A is equal to B. And you may notice it's two equal signs. It's not one. That's going to give you an error. And in different languages actually means something different. Sometimes I think in Java, if you use equal signs, it means you're comparing not their value, but the actual like strings. So like if I had A was equal to the string Janet, and then B was equal to the string Janet but capitalized, it would compare the letters, not their actual value, not if that makes sense. So we have the two equal signs, then we put colon again, then enter. So if A is equal to B, we want it to print A and B are equal. And sometimes we also want to deal with neither of these conditions are true. So we dealt with B being bigger than A or A being equal to B. Then all that's left is for B to be less than A. So instead of us having to say, hey, if A is greater than or less than B, do this, we can just say, hey, let's just do an else statement. And when you do an else statement, you don't put anything next to it because there's no condition. Else just means if the if statement isn't true, do this condition. It just means if all else fails, run this. So we're gonna do else again. We press enter for it to indent, and then we just put print I don't know, whatever you want. I'll just put other. So and then we run it. So none of my conditions are true. So it prints other. But what if we were to make them equal? What would happen? Hold on. 33. It prints A and B are equal. But what if A was to be greater? Then it prints B is greater than A. Are we all good? Is it making sense? Okay. But sometimes in Python, it can be a little bit more complicated than just B is greater than 8, right? So let's get out of this if statement and let's create new variables, right? So I'll just do, what is it? I'll just do A is equal to 2. Make sure you're at the very start of your cell because it's gonna give you an error. So don't indent, just be at the very beginning of this line. So we're gonna do A is equal to 200, B is equal to, let's say 33, and C is equal to 500. And you might be wondering why I'm renaming these variables if I also have them up here. Well, when you're writing code, the last assignment is actually what counts. So when you're programming, it reads things in order. So in these first few lines, A and B are equal to these numbers, but now I get to here and I just reassign their value. So now it's not going to think like, hey, I'm confused. Is A equal to 3 or 22 or 200? It takes your last count right here. So let's see. Now we want to do like, what if I only care about one being true, right? So I can do if A is greater than B, right? And then key statement, or you see how it highlights in blue, that means it's a reserved keyword in Python. Let's say if A is greater than B or A is greater than C, colon, again, enter, then we can print at least one condition is true. So when you use the or in conditional statements, only one condition has to be true. Only one. Now, Python actually has it to where you can have, both conditions be true as well. So like, what if we want, spelled wrong. Else if, let's say I want A to be greater than B, keyword and. So if you guys have taken discrete structures, or means one or the other or both, or one or the other, and then and means for this to run, both conditions absolutely have to be true. So we can do and C is smaller than A, and then again you need to put the the colon, enter. We can just print, print both conditions are true.
So kind of going back to what you're saying, how there's the A is greater than the A equals 100, you said it would just, so do you mean that it would choose the most recent one you did for A?
Yes. So it reads things in order. So for these lines right, we won't highlight. For these lines right here, it takes A and B to be these two variables right here, because as of right now, it only knows that A is equal to 3 and B is equal to 33. But then when I get to this line, I just reassign their value. But it only reassigns it from this down, not this up. So now I just reassign these numbers and values. Yes. Yeah. Else if A is greater than B and C is less than A colon. Hi. Oh gosh. Hey, can you help him catch up to where we are? Yes. Okay, are we all caught up? Are we good? Okay. So can anybody name the difference between the or and the and in this? Okay, so next I'm gonna create a new cell. Again, you just click the plus sign because I think I did a lot in that one. So the next thing that we're gonna learn is a while loop. So there's a lot of different conditional statements in every coding language. There's if statements, for, whiles, switch, like it just goes on. So I think if and while are used the most, at least for me. So like we'll do while next, right? So a while loop, it just means that hey, as long as this condition is true, keep doing this over and over again. And once it's not, then you stop, right? So let's create a variable called I, right? And let's put its value to 1. And let's say while, again, you see it's in purple. That means it's a reserved keyword in Python. If I is smaller than 6, or whatever number you want to use, do this. Again, I is a placeholder for this number 1 right here. So is 1 smaller than 6? So it's going to keep running until 1 is not smaller than 6, basically, right? So like, let's say print I. So when I is smaller than 6, just keep printing 1, right? And if I do that, it creates an infinite loop, which means it keeps running. Do not create infinite loops. I did it once, my computer shut off because it runs forever. It does not know when to stop. It will kill your computer. So don't do that. Because do you see 1 never increases? So like this condition will always be true to the end of time unless math changes. So your computer will keep running to the end of time. So to stop that, let's do an if statement, right? Let's do if I is equal to, let's say 4, break. And you might be wondering what this break means. It just means stop. So whenever I becomes 4, it just stops running because that condition is not true. If you were to put continue, it would continuously print the number 4. and it won't stop. Like it will just create an infinite loop all over again. So make sure you know when your loop ends. There's something called a base case when you talk about recursion. A base case is basically telling your computer, like, hey, keep running this over and over again until you reach this condition. But if you keep running something forever, it means that it has no condition to say, hey, stop now. So like it just says break. And then let's go back here. Let's put I plus is equal to 1. And now this might be confusing, but this is actually just the same as I is equal to I plus 1. So this means whatever the current value of 1 is, of I is, add 1 to it. So we're just incrementing it because eventually we do want either this condition to not be true anymore or that one. So let's run it. If you notice, it prints 1, 2, 3, and 4, and it stops at 4 because we have this break right here. But let's just try to put the word continue. It keeps printing 4 forever. Because do you see how do you see the indentations? If I highlight this right here, the if statement only runs this. If this condition isn't true, that's when it goes to the next one and it keeps rerunning. So as of right now, I is equal to 4 because we're incrementing, right? And I is equal to 4, it just means keep continuously doing this. It never reaches this for this condition to not be true. So again, this is an infinite loop, which is why we want to use break. Yeah. So it stops at 4, and if you want, you can even have it stop at 5. And now it prints 1, 2, 3, 4, 5. If we want, we can change this condition to only stop whenever I is equal to 6, whatever it may, like you can do different things with it, but just don't create infinite loops. That's never ever good. Next thing, you can use a for loop for a lot of different things, but I want it to continuously print a range of numbers, right? So like, let's say you wanted to, for some reason, print the numbers 1 through 10. I do not want to type 1, 2, 3 through 10 by itself. I'm a lazy programmer. I'm not going to do that. So we can just use a for loop. So we'll just do for. Pick a letter that I haven't used yet. So we'll just do X. So for X in range, and I'll do, let's just say 2 and 6, colon, enter, print X. Now you might be wondering, what does X stand for? It's like for everything that's between the range of 2 and 6, print it. So when you print this statement, you're gonna notice something. I say in range of 2 to 6, it prints 2, 3, 4, and 5. In range, it does not include the last number. So it does not include 6. But if I do to 9, it's going to print all the numbers except for 9. So it just means start at 2, but don't print the last digit. And in Python, there's actually some things where you can say, hey, print the numbers 1 through 100, but skip every third number or whatever it may be. But yeah, so this will always mean print 2 through 8, but do not print 9. So we have 2 more things to learn before we go into like the machine learning aspect of things. So in Python, you can also create functions. A function is like a block of code that only runs when you call it. So imagine your body, you have your arms, your legs. Instead of them having to have their own body parts, you could just call, like it's just all connected. So we can make a function called, you start by saying def. I'll just call it my function. Do not call it function. That's a reserved word in Python, meaning you can't use it to name things or be a placeholder. So I'll just call it my function, and then inside I'll put f name and then L name for first and last name, meaning whenever you call this function, you also have to enter 2 values, and they have to, be these 2. So colon and then excuse me, enter, let's say print, and I'll say print F name plus L name, last name, plus quotation marks. I'll just put hello. So this means print this value, sorry, print the F name and L name, and then add hello at the end of it. So if I was to run this, nothing would happen because you have to actually call it outside the function for it to work. So if you notice when I did this, it indents to be aligned with the print. Whatever you type in this alignment is only going to run when you're in the function. We don't want that. We're calling the function from outside. So now you just type in its name. And if you see Python saved your function name because it's, a function is defined. For it to actually run, now I have to enter the F name and last name. So I'll just put your first and last name, excuse me. And whenever I run this, it prints it really badly because I didn't add spacing. There we go. Janet Zulu, hello. So you give it inputs and when you call the function, you give it the 2 inputs that it's requiring, then it does whatever is inside this function. But there's also, are we all good? Any questions? Okay. There's different ways to create functions. There's also something called anonymous function. It's called a lambda. So how you do that one, I think it's a little bit easier depending on what you want to do with it. So I'll just use the letter B, right? So B is equal to lambda. And I'll just pick 2 letters. So I'll put A, comma, B, colon, let's do A times B. So this basically means it's just a function basically. So it means take these 2 inputs, take A and B, then you have the colon, and then do this once you have the inputs. So now that I have it, I actually have to call the function, right? So I'll just do a print statement so you can actually see it. You have to call the letter, right? So it needs to know what you're calling. So I named mine B, so I put B, and then I put parentheses, and then I put 5,6. You can pick any number you want, but we put 5 and 6 because when we defined the function, we said, hey, take these 2 inputs, A and B. My A is 5 and my B is 6. And once we have these inputs, you need to do what is right here, which is A times B. You can put A minus B, whatever you want. So now when we run this, it gives me 30. Where's 30 from? 5 and 6 is equal to 30. And you might be wondering, like, oh, like, what's the point of using functions for these little words? Well, for different reasons. So instead of me having to continuously write certain functionalities, I can just keep calling the function and giving it input, and it'll just keep doing the same thing over and over for me. It's just a way to save time and also space. Does that make sense? Are you good? Okay, now we move on to some machine learning. Kind of nervous. If you're using Jupyter Notebook or whatever, or what's this there? In Jupyter Notebook, you might have to variables in a function, don't variable in this. Okay, sorry. You might have to run this command in Jupyter Notebook. It's called pip install pandas. Now, if you are using Google Colab, then it already has it. So you're good. But if anyone's in Jupyter, or just make sure it has it, to just run the command pip install pandas. So if you're ever using Jupyter Notebook, or sometimes even in PyCharm, you have to install certain libraries. You have to use the keywords pip install the name of the library that you actually want to use. But in this case, we already have it, so we're good. You guys all have it? Good? Are you good? Are you good? Okay. So pandas is a Python library that's used for data analyzing. So it has a lot of capabilities, like it can clean data, it can fix data, it can also like analyze, it can make graphs, charts, whatever you need it for. But today we'll mainly focus on opening, fixing, or cleaning some data, nothing heavy. So if you go to Discord, if everyone's on there, I put a file in the workshop information. Just download that file to your computer. Are we all in Discord? Are you? Are you? It's in the workshop information. Do you guys see it? Do you have download it to your computer? Just click like download symbol right here. Wait, how's it showing up? It's in the workshop. Yeah. You have it. Okay. You guys have it? Yeah. We're done. Yeah. It's just like I have never. You guys have it? Okay, so now we go back to Google Colab or Jupyter, whatever you're using. Excuse me. And now we already installed pandas for data analysis, but now we actually need to import it. So on your computer, there's millions and millions of libraries. Instead of your computer having to search through and find things, you just tell it. So what we do is we type in the word import. pandas. So it means, hey, import the pandas library. But here's the thing. Some Python libraries can be very, very long. And I mean very, very, very long. So we create shortcuts to reference them. So we just do as PD. So now to reference pandas, we just type in the word PD for a shortcut. So now, who's using Jupyter Notebook? Okay, this step might be different depending on what you're using. So if you're using Jupyter Notebook, create a variable to hold, like I just used house, and then type in PD to reference pandas dot read CSV because this read underscore CSV is from the pandas library, so we have to say PD dot read CSV, and then type in the file location to your computer. If you're using Google, it's very different, so I'll get to that. What are you using? Yeah, are you using Jupyter or Collab? Did it work? Hey, Ariana, did it work?
I'm sorry.
Okay, if you are using Google Collab, we're going to do it like this. So it's a little bit more complicated when you're using Google Collab. And if we go to a hackathon, please install Jupyter to avoid having to do this over and over again, right? So what we do is we type in from google.collab, and we do this because we are currently on Chrome. We are not in our computer. So if I just put in the file location like I did for Jupyter, your computer is confused because it's like, I'm not sure what C drive users Janet means because you're not in your computer. So if you're using Jupyter, it's installed onto your computer. So it says, okay, go to this location. But when you are using Google Colab, it's different. So you have to type in google.colab and then import files. And then I have to create just a random variable. I'll just call it upload is equal to files dot upload, because this actually enables Google Colab to go to your computer and find the file that you want to use. Scroll up a little bit. Are we good there? Good. Okay. So now we have to create a path. And I think the file name is like price examples dot csv, I hope. And then I want this data to be stored in a variable called house. So I'll do house is equal to PD. Remember, that's just referencing the pandas library. PD dot read. You see how it comes up right here? You can read different file types. You can read HTML files, JSON files, PDFs, Excels, SQL files, but we're going to be using CSV because, as you see, our file is a CSV. And then you, excuse me, actually put in path. And let's see if this actually works. When you run it, it gives you this right here. You have to click file. And then if you did download the file, it's just click on it in your computer and then click open. And now my file is uploaded. Are we good? Yes. Sorry, keep forgetting. So, choose files. Yeah. Whatever. Oh, it's an I. You can speak in exactly what you're plotting.
Yeah. No, like. Yeah.
So now that we have the file, what we're gonna do is whatever you named it, type it in by itself so we can actually see the contents of it. If you're using Google Colab, it's gonna be really stupid because it makes you reopen the file each single time. If you're using Jupyter Notebook, you just do it once and you're good. So I typed in whatever I named this variable that's holding your CSV file. If I run it, for me, I have to open the file again. Then it gives me my file contents right here. So I have size, rooms, price, and just random. Is that working for y'all? Good. Okay. So sometimes our data is not going to only be 20. It can be thousands, hundreds, whatever it may be. And sometimes one thing about when you're doing machine learning is the amount of RAM you have in your computer matters. Not every computer can actually do machine learning because you may not have enough RAM for your computer to actually run your data because this stuff can take days, hours, weeks, months. But our data only has 20 because, it's just the workshop. But what happens, sometimes we don't want to use all of our data. So imagine you go to a website to download their data and they give you a file with like a million columns, a million rows, whatever it may be. Your computer might not do well with that. So what we can do actually is we can limit the number of rows, right? So right now we only have 20, but after the path, you do comma and rows. Then I'll just do 10 because right now I only have 20, right? And if I run that, I have to open the file again. it now only prints 10. Yeah, like that. Oh, I'm sorry. So adding n rows is equal to 10 limits it. I remember, I think for the hackathon, I think our data set had like 90,000 rows, and that's very heavy for a hackathon, and we didn't want to sit and go through all of it. So we have to just limit it to like 10,000. So you need to remember that. I'm going to create another cell. So now we're going to learn something real quick. So sometimes we need to make sure that our data was imported correctly. So Python has this feature where you can just do whatever you named it. Like mine is house.head. And if I run this, it prints the first five rows of your data, because sometimes you just need to see if the values are correct, if it imported correctly, because sometimes when you're working with like CSVs or different file types, it can kind of convert different file types in a very weird way. So you just do house.head to just see the first 5 rows, because if you're working with like a big data set that had like over 1,000 rows, I don't want to see all of that. Like just show me the first 5 and I'm good. Or also you can also change head to tail, and it actually just shows you the last 5. And if you notice, it's only showing me 5 through 9, because up here we did limit our data to only 10 rows. But our data isn't that big, so I'm going to actually delete that because I want to see all the columns. So I have to rerun that. Choose the file one more time. Or I think the last time now. Run that, and now it's displaying all files. You might notice that it goes from 0 to 19 again, because in Python, it starts counting from 0. So 0 to 19 is 20 digits, but the first index is always 0. So we have 20 values. Okay. Next thing that we are going to do is, do you guys notice how in our columns we have this column called random? NaN just means it has no values, which means it has literally nothing. It's just like if you go to the Excel sheet, it just has no values. In Python, it won't just leave it blank. It goes in with NaN. What you can do is, if you don't want them, you can either, I think the command is like drop NA. That means drop on no values. Yeah, right there. But what we're actually going to do is delete them in a different way. So how to do so is we type in house again to actually reference our data. So we do house dot drop parentheses, and the column name, oh, let me scroll up real quick. It gives me an error because there's nothing in there. Drop, and then do you see how our column name is just random? So we're gonna put quotations, random, comma, we do axis is equal to 1. So when you're working with data, axis 1 means column, axis 0 means rows, and we don't want to delete the row. We want to delete the entire column because there's nothing there. So we do axis is equal to 1. And now do you see how it's gone? Like there's no more random row. That's exactly what we want. So we have to clean our data because when you start to like train our model, we want to avoid sending in useless data. If the data has no value, delete the data. It can actually mess up what you're trying to do. So we just deleted it. But what actually happens is this is temporary. To make it permanent, you have to do something called comma in place. And this in place is actually what makes it permanent. So like if I don't have this in place here, if I was to type house again, it would have the random column show up again. But I want it gone permanently from my data set. So I type in that, and now it's just permanently gone from my data. So if you were to put false, it just means just do it for now and bring it back later. And we don't want that. Are we all good? Okay, so sometimes when working with data, we want to know the stats of our data. So let's say we just get a random data set from the internet, which don't do that. That's not safe. Check your data first. But if you want to see how many rows, columns are in there, there's a way to do that. So you type in house or whatever you named your pd.opencv, and then you type in describe. So if I was to run this, oh my goodness. Let's delete that real quick. It gives me a lot of statistics. And then it gives me for all the columns that we currently have for size, rooms, and price. It gives me how many values are in each column. So if I was missing data, it would give me very different numbers, which is why we have to delete that random because it's just useless data. It gives me the mean and all of these other stats. These things do matter, but not for what we're doing. So we're just gonna skip that. Now this part is gonna be a lot of copy and pasting. I'll just give it to y'all. That's a lot to write. I'll just paste it in the Discord. So I'm gonna open a new cell and I'm going to import a whole bunch of stuff. And just go to the Discord. I pasted something in the workshop thing. Just paste it in a new cell. I say Jupyter Notebook because it's on your computer, so accessing your data is a lot faster. But also, when like you have to rerun it, if you noticed in Google Colab, you have to keep opening the file, which I think is annoying and tedious. In Jupyter Notebook, it just does it for you. Yeah, just one time and you're good. Just little shortcuts.
And for the house describe, is it just getting the basic? What did it bring for you when you put house describe? Oh, okay.
Yeah, it prints like all the stats of the data. I think we have the same data, so it should all be the same for us. And I had a little note I need to also.
Oh, it's mine has the random items in there.
Okay. So scikit-learn is a library that stores a lot of like machine learning modules. So a lot of the algorithm that it uses, it already has an algorithm that they're already pre-made for you, so you don't have to write the code for it. which is why we use it. So we have to first say scikit-learn, that's what this stands for, dot linear model import linear regression. And now all of these things, except for this one, are all algorithms. So linear regression is right here. It's a machine learning algorithm that it tries to find a linear relationship between a set of input variables and a target output variable. And the goal of it is to create a model that can predict the outputs. So when I say linear regression, I want you to imagine this. I think it's the easiest algorithm that you can ever use in machine learning because the equation for it is literally y is equal to mx plus b. That is the easiest equation you would ever come upon in machine learning. So what it does is, imagine this, and we have different variables here and here, and we have all of our data. It makes like a little line right there to see a relationship between all the inputs, and then it puts it against the outputs. This is the easiest equation you can possibly, ever use. So when you're doing machine learning, one thing to really remember is most of the time your input variables are independent variables, and then your output are dependent, meaning your output is dependent on whatever you put into it, right? So like when you're doing math, the answer is always dependent on your inputs. So if I was doing like addition, your output is dependent on what two variables you're actually adding. Make sense? Okay, so that's what linear regression tries to do. It just tries to fit, thank you for coming, tries to fit a straight line through the points on the graph. And again, it's just y is equal to mx plus b. And then, okay, I'll do random forest next. So random forest, it tries to create different decision trees. So how can I explain it? I think I took a picture of it. Hold on, let me see. Actually, can you guys see that pretty well? Is that blurry? Okay, so we give it a data set and it creates like a bunch of like a lot of decision trees. And when I say decision tree, imagine you had a, let's see, let me just send this to myself real quick. I think it might be a better visual. Is it taking so long? What? I'm sorry, guys. Give me 1 second. Trying to find the picture. Okay, I guess it just doesn't want to work. Okay, so I'll just draw it out for you guys. So imagine we were this. Imagine we had a graph or a table that had color. I'll just put, it stands for like diameter and then label. Right? This is our table instead of the house one. And then we have the colors green, yellow. Let me see if it finally arrived. I'll just put, and then yellow again, and we had like 3, 3, 1, 1, 3. Then we had fruits, apple, grape, and then lemon randomly. What a decision tree is let's say at the top, right? So you see how we have these diameters right here. We can ask ourselves, is the diameter 3, right? The options are like true or false, right? And again, this is like the diameters right here, 3 or 1. Is the diameter 3? We can do this side can be false, and this side can be true. Is the diameter 3? Yes, it is actually for these and this. So I'll just put it's true for the color green. It has a diameter of 3, and the label is apple. And I can do that twice because this shows up twice. Color is yellow, but it also happens down here where the color is yellow. The diameter is 3 and the label is lemon. I'll just put L. So this is for true, but it's also false for R1 and grape. R1 and grape. It's false for these. So now I'm at a different node. And now I can ask myself, is the color equal to yellow? Meaning of these conditions, whose color is equal to yellow? Well, it's only true. Again, it goes to true or false, and it's only true for these two, right? The yellow diameter of 3 and apple, yellow diameter of 3 and lemon. But it's false for the color green, the diameter of 3 and apple. And this is just coming from here. I'm just using like the first letter, like green, yellow, red, yellow, whatever it may be. So that's how a decision tree is made. It just creates like different trees of different conditions. And then now it says, okay, I'm at the end. Can I predict what's next? So maybe it can make the prediction that on this node that the next fruit that's going to be here might be apple or lemon. So it makes like different factors to decide what should come next. It might be true or false. It could be, is 1 bigger than 3? Like different. It just depends on your data. So if we go back here, oh gosh, that's what that means. And then there's also something called train, test, split. So when you are doing machine learning, you need to check the accuracy of your data. So you have to split it into training and testing. So you give it a set of outputs for training, meaning you're just saying, hey, use these three different algorithms to find a pattern between these numbers. I'm gonna give you a set of outputs. Excuse me. Create a prediction between these, create a predicted output from these inputs, and then compare it against the actual input and see how accurate you were. So you're just checking how well your machine is able to detect certain things, right? That's what the train test split does. So I'm gonna do a new cell, and I'm gonna create so we have to initialize to actually use these. So we did import them, but we actually can't use them yet. So now I'm gonna just do model LR for linear regression. That's our first algorithm, is equal to linear regression. And your computer already knows that one, so it might help you fill it out. And I have to do this for all 3 of my algorithms. Then I can do model NN, that stands for neural networks, is equal to MLP regressor. Next, model RF for random forest is equal to random forest progressor. So now I'm actually able, question? Oh, yeah. Can you see that? Sorry, guys. This is already in Discord. You can just copy and paste it. But yeah, I did model LR for linear regression. Then I actually called linear regression, which we imported up here. Then I also called neural networks right here, then random forest. So instead of like this, just gives us a way to actually add data into these algorithms. So I'm going to do a plus. Don't forget to add your parentheses at the end of each of the algorithms. So now in Python, in Pandas, you have to decide which data is your input and what's your output, meaning what goes into your training and what goes into your testing. So if you look at our data, we have columns 0, 1, and 2. So Python has this function. So we'll just do, let's just do x is equal to house, or whatever you named your data frame. House.ilog, it's just like location of what you want, and then brackets. And then you can say, or brackets, comma, you can say 0 semicolon 2. This means for x, we're going to print 0 to 2. It's the same as the range that we had earlier up in the for loop, 0 to 2. It's only going to include 0 and 1, but it won't include the column number 2. So if we go up here, we have 0, 1, and 2, whatever, however it counts it, it won't count price. It only takes in these two, the size and the room. Good. Okay, that's our x. Now we need our y. So house.ilog, again, brackets, colon, comma, and we're doing a comma because when you're working in Python, you have to do rows and column, but at this time, we're only working with our columns. So now I'm going to put just 2. So this will only include the index column 2. So our x is, what is it? Our x is size in rooms, and our y is price. And we didn't put anything over here because right here, whatever goes right here is reserved for the rows. Again, it goes rows, then column. But right now, we don't care about the rows, just the columns. So that's why we put it at the very end. And again, the 0 and 2, it means include 0 and 1, but don't include 2. And then here, it just means column 2. And now if you actually want to see what you just did, you can just type in X. Oh, sorry. There we go. So do you guys see how like we put in a 0 and 2? It just counts the columns 0 and 1, but does not include 2. So you only see size and rooms. But if we replace it with Y, it only prints the last column, which is the price column. Make sense? Isaac, are you good? Okay. Oh, almost done. Okay, so these algorithms, they're basically meant for you to create a model. You tell your computer like, hey, I'm gonna give you these inputs. I need you to split it into training and testing data. The training data is for these algorithms that we made, the 3 algorithms. It's meant to only test for, it's meant for them to test their accuracy. So I give it to these algorithms and they all have different math. So it uses like different math equations, whatever, to find different patterns. and then the output data, which is the price. So basically, like how we're doing it is we're trying to see if it can predict the final price based off of patterns of like size and rooms. We're saying, hey, can you predict the price? And at the very end, we're gonna actually give our model the testing data. I'm gonna say, hey, okay, you made your predictions. Now actually test it against your testing data and see what your accuracy was. The accuracy is always from 0 to 1. You want to be very close to the number 1, and I mean very, very close. So now we have our data. I'm going to do a new cell. This part might be kind of long. So I have to split my data now into X training, Y training, X testing, and Y testing. So I have to split my data into training and testing. Excuse me. So I can do, I'll just do like X train, comma, X test, Y train, Y test. And I'm going to make that equal to train underscore split. And this train underscore test underscore split, it comes from this import right here. So now we're able to create our model, but we have to split it into testing and training data. So once we're here, we create parentheses and we put in X and Y. And oh, what's happening? This X and Y is just the X and Y that we made up here. So now we actually have to feed it the columns that we made. So we do X and Y. At the end of Y, you do comma, test. Oh, what is happening? Test underscore size. So now you have to define the size of your data. So it's using decimals. So right, we have 20 columns in our, 20 rows in our data. I'm gonna do 0.2, meaning, hey, take 20% of my overall data and try to find a pattern. I'm gonna give you the other 80% and test your accuracy on it. You can use any number that you want. You can do 0.3, point whatever. It's up to you. And now to see what actually went into these variables, I'm gonna do xtrain and see what pops up. It gives me an error. It's not, oh gosh, okay. Make sure you run this column, it might give you some issues. Run that column, run this one, and then run this one. Okay, there we go. So xtrain has all of these values. So these numbers here, we should have, I want to say 14 numbers here. Because 20% of our numbers, they went into, we should have 16. 20% went into testing. And right now, that means that our training only got 80%. So it's coming out of 100. If we sent 20% of our data to testing, then 80% is in our training, right? So that's what that means. So now if I was to type Y train, it would also give me, sorry, do X train. X test, I'm so sorry, X test. It gives you 4 values because 20% of 20 is just 4. So it gives you 4 values. These 4 numbers are what's going to be sent into your test. If you keep refreshing it, you might notice that you get different numbers. We don't want that because let's say you're at a hackathon, right? And you're doing algorithms. And let's say you run it today and you run it again tomorrow. What's going to happen is your numbers are going to drastically change, and that's never a good thing, ever. Because that means things would take very, very long to run. What is it? I think it's called random state. Random underscore state is equal to, is it 1? Let me see. Yeah, okay. So if you do random state is equal to 1, that means every single time you run your data training or testing, it's going to use the same numbers. Which I think it's very important because it makes it easier for you to generalize your outputs in your algorithm as well. So without random state, it's going to take in different inputs and outputs every single time. But if we add random state is equal to 1, it makes it to where it uses the same exact data. So if you keep refreshing it, it's going to keep using 3, 16, 6, and 10. And same for all of these other values. We all good? What? Oh, yes, sorry. Thank you for coming. Do the interest form.
I did.
You did?
Yeah.
Okay. Guys, are you guys good? Point two, not test signs and even decimal, because again, it comes from 0 to 1. So you can, I mean, 2, it would make sense, or 20%, but it's using decimal. So the 0.2 means that we sent in 20%. Okay. Okay. We're gonna move on. So now that we have our data, we can actually put our data into the algorithms for it to do all of its wonderful math and, you know, train itself. So I'm gonna call the model LR that I made before dot fit. This dot fit just means, hey, I'm gonna give you this input. I need you to run your math and find patterns. So dot fit, and you put X train and Y train. Because again, this dot fit, we're trying to train our model. This train means use your math to find whatever patterns. And you do that for all of the models that we created. So your networks dot fit, X train, Y train. So now we've sent in all of our training data into all 3 algorithms that we're going to be using. And again, each of these algorithms, random forest, neural networks, and linear regression, they all use different equations to find patterns within the same data. And then towards the end, what we do is we test it to see what was the most accurate. So once you fit, it just looks for patterns. And once you finish that, run it, and it might give you this. This is actually for a very good reason. When you're working with different algorithms, it has different hyperparameters. This just means that, hey, in your random forest algorithms, I really think that you can change some of my algorithm a little bit for me to give you better accuracy. Bless you. But we are not messing with those today because that's complicated. But if you got this, it's fine. That's fine. Now, if you got an error, that's different. So now, we can actually test our, thank you for coming. So now that we have our model, we can actually test it against our outputs, right? So what I want to do is I want it to print out the scores that it gave me. The outputs are going to be numbers from 0 to 1. Again, we want to be as close as possible to the number ones. Like we want to be like the 0.995 and above. That's usually where you want to aim. So I'm gonna do a print statement. I'm gonna type in linear regression for our first algorithm. comma, I'll type in the model again, the model for each of these, and I'll type in LR dot score. This means, hey, this dot score, it means, hey, I already gave you my input data, and I'm going to give you the output data, compare against what you got and see how accurate you were. So dot score, and then I type in X test and Y test. So now this is our testing data. And you do that for the other two algorithms. Huh? It should be neural. Oh, I just got it very, very wrong.
But I don't see why. And you want to just run this one and then go up to where you define model R and then rerun those. Yeah, just rerun all of them.
Okay, so now you can now run this column. And do you see what numbers it gives you? Very high numbers. No, there should be, so they're all different algorithms. So we're testing which one is better for this, right? So for mine, linear regression was the best for what I got because it gave me I got very, very close. Or actually, no, neural networks was better because I got very, very close to 1 because the accuracy is scored between 0 to 1, and the closer you are to 1, the better. So for me, neural networks is better than random forest. Our numbers are different because when we put training and testing, it took in different, we all got different numbers, different inputs and outputs. Did it work?
Oh, probably back, yeah. Oh, that's why.
Just rerun them. It might not, yeah. That's the problem. Yeah. That is never good.
because all of us are. Like,
So what worked best for you guys? Like which algorithm worked best? What was yours? It didn't work.
No. Yeah.
Was it like a 0.99? Was it the
Yeah.
0.99.
The reason why, let me check the comment real quick. Linear is winning for all of that except for me. Huh? Neural? Yeah, okay, feel better. Not for me. Wait, did it? No, neural one. But okay, but think about this though. Like when you're working with data right now, we're literally only using 20 rows. Realistically, you're gonna be working with like thousands, hundreds, whatever it is, right? So for 20 rows, this is very good. But the reason that we use the random state is equal to 1 is because we want to be able to replicate this, right? So like if I was to increase the data set to now be like hundreds, these numbers would probably be very different. They would be a little bit lower, could be like a 0.88, which is not the worst, but you want it to be very, very accurate. Now there's like 1,000 different algorithms, so they all work differently. For example, there's one called logistic regression. That one, it gives you better accuracy if you're using like binary inputs, meaning if it's like a true or false question, if it's 1 or 0, if you only have 2 options, that one will work best. So there's different reasons why these work differently. I think it's funny that y is equal to mx plus b worked best for y'all, but I can see why, because if you go to the data, if you look at the 100 to the 2 and like their prices, it's pretty linear. I can see why that worked. It's increasing at a very like steady pace, so I can see why it worked, I guess. So good for y'all. So that is all the machine learning that we're going to be learning today, but there's one more thing that we are doing. So at the hackathon, a few of y'all were using GUIs, right? Yeah. Does anybody know what that stands for? GUI? Have you guys ever used, what did you guys learn, Java? Have you guys like learned like Java effects? Okay, so a GUI stands for a graphical user interface. If you, sometimes when you're programming, right? Let me see. Yes, if you're programming, sometimes you don't want to just use print statements. Like you actually physically want to create like a visual project, right? That's basically what a GUI is. So in Python, you can do that. There's a library called Tkinter. I could be saying it wrong, but let me see. So if you're in Google Lab, this won't work. But if you're using like PyCharm, then this will work. So this is called Tkinter, right? So first I have to import it in this first line. Then I have to import it again. And then instead of having to call it Tkinter each time, because that's very annoying, instead I can just use TK, right? I have to do something called root, which means, hey, can you actually create this window for me? Excuse me. And then I have to create the geometry of it, meaning like how big is your window going to be? Now this is different. It's by like screen size. So if your screen is less than this, which is unlikely, it'll just be smaller on your screen. And then I can give it a title, right? So like, for example, I'll run mine. That's a GUI. It says, welcome to our demo. Hello, vote for Deanne for SGA president. You actually should though. She is. She couldn't come because she's campaigning today, but maybe I'm biased. But yeah, so that like you can create buttons on it. Like if I actually had like a command, I could actually run this. So like I do have like different GUI projects like is it this one? No. This is from my software engineering class. And this is my GUI. What it basically does is there's something called UML code. It's a type of graph that you guys will eventually learn. It's actually really important in software engineering. I can either paste my code and it'll help me create like a UML diagram, or I can upload a file from my computer instead and just do it that way. But it actually does work. Then I've also done, do I even still have it? Open, what is it called? Movie ticketing. This is, we made like a movie ticketing database. Like when you go to the movie, like you have to like, order your ticket, name, whatever. I hope it still works. So if I was to run it, you're able to enter all this information and it gets sent to a database. These buttons, they all work. Like they actually, so this is actually pulling data from a real database. So it's very interactive. I can delete certain things. I can edit certain things. That's basically what a GUI is. So if you don't like print statements, this might be what you do. And in Python, it's really easy because as you saw, it took like barely any code to actually create it. I forgot what it was called, but that's what a GUI is. So you have options. But that is literally the end of our workshop. Yeah. So did you guys learn anything today?
Yeah.
Okay. No. Yeah, that's unfortunate. So next week I hope to see you guys at our machine learning with Tony. It's gonna be held site tech room 165, I think. It's going to be going deeper into machine learning. So Tony's actually very good at machine learning. He has a lot of grants for it, a lot of awards for it. Like he's the person for it. He can teach you a lot of it. He's like a very good professor. So I'd highly recommend coming because for the hackathon, you never know what they might ask you to do. And he also does research. So if he sees you at his workshops, and like, okay, like, you know, she was here to learn. I like her. I might want her for my research, and you know. And I think we might have pizza. That's a rumor. I can't confirm. It's just a rumor. I really can't. So like when you go to a hackathon, they have a website, right? Hold on. So this was for the Tamu hacks, and they had like different challenges. Oh my goodness. They had all of these different tracks, right? So for example, my team did this one. It says design an app or system that helps GM accomplish its goal of 0 crashes, 0 emission, and 0 congestion. So now like you have no structure. It just means, hey, whatever you build, just make sure it meets this criteria. It solves this problem.
Like,
Well, you have you already have different projects. Like they like sit in rows and like things. Wow. Yeah. I think their team like for my team, like we have to wait for a while. Wait for the there for a while. I'm ready. Thank you for coming. Yeah. Yes. Yeah, my team won this one. Or the day of, like, it was gonna be on sleep. Cause like the one, like I think that from the best airlines, Yeah, they even have like they give away iPads, they give away monitors, they give away Beats. Thank you for coming. They give away Beats, like they give away like a lot of different things. This challenge, Google is gonna be there, and they're usually known for giving away, you know, drugs. Take it however you want.
So like, okay, 'cause